Hello everyone. Note down this question. We have a rough incline and this angle is theta. An object of mass m, moment of inertia I and radius r is released from height h. Initially the body is at rest and question says that friction is sufficient. So the question is what? We have an object of mass m, moment of inertia I, radius r. It is rolling down an incline where friction between the body and incline is sufficient. And you know what does it mean? When I say it's sufficient, it means you can have pure rolling. Pure rolling is allowed. When it reaches bottom of the incline at the lowest point, find out its velocity. Note down the question. This is the incline. You have a body, you release it from rest, it rolls down, and as it rolls down, it gains some speed v, which you need to find. Height initial is h. There is sufficient friction present so that you can have pure rolling. Let's answer this question step by step. First thing, let's see how much you remember from the previous lecture. What is the direction of friction on this rolling body? What is the direction of friction on the rolling body, up or down? Good. Friction is going to act in this direction. This is the direction of friction. Now, this friction is mu mg cos theta. Yes or no? The friction acting on the body is mu mg cos theta. Yes or no? Answer these things step by step. Only one person has answered. No, it's not. Fr is mu mg cos theta. It's a special case when contact point is about to slip. There is no mention of about to slip. We have been told that this contact point is not slipping. That's all. If it's not slipping, then Fr will be anything less than or equal to mu mg cos theta. This is something which we have already done in the previous lecture. Now tell me this, whenever we have done questions like things coming down on an incline, in laws of motion we have used COME for these questions. Can we use COME in this question if friction is present? Write down yes or no. Friction is acting on the body. If you remember, friction is non-conservative. And if things are non-conservative, I hope you remember we cannot use COME, but in this case we can. Although friction is acting on the wheel, we can still use COME. Now if I have told you that we can use COME, then is there anyone who can clear this thing for each and everyone, that how can we use conservation of mechanical energy although a non-conservative force like friction is acting on the body? Is there anyone who can? Once I say that we can, explain the concept. Look, when we say that friction is non-conservative, what happens? Because of frictional forces, loss of energy takes place, and that loss comes out in the form of heat. What type of heat? If you rub your hands against each other, what happens? Heat is coming out. That means loss of energy is going to take place. फिर से समझना, अगर आपने अपने हाथों को एक दूसरे के अगेंस्ट इस तरह से होल्ड किया, but you're not rubbing them, you're just holding them like this. If you're not rubbing these hands, then does it generate any heat? And I hope you can feel this. Answer is no. How can you generate heat? By rubbing your hands against each other. If you are simply holding them, friction is acting, but no heat is coming out. So what is special about this? This means no relative motion. This means relative motion is present. What about pure rolling? Pure rolling means this contact point is not rubbing against the incline. And since it doesn't rub against the incline, there is no heat coming out. If no heat is coming out, that means there is no loss of energy. If there is no loss of energy, we can conserve what? Mechanical energy. Which gives us a very important question, a one-liner. Friction is present on a body. Can we use COME? Yes, we can. Can we always use COME? No, not always. If no slipping takes place, then we can always use what? COME. How many of you understand this logic? If you are comfortable with the logic, then write down yes in the comment box fast. If you think that you are comfortable with this complete thing, good. In fact, write down the whole statement. Although friction is acting on the body, but during pure rolling, as no slipping takes place, no heat loss takes place. That is, there is no loss of energy and we can conserve mechanical energy. We can conserve mechanical energy. For friction, it was this much easy. There is no relative motion, no slipping, no heat loss, and therefore K and P, this sum will remain what? Conserved. इसको और अच्छे से समझेंगे अभी थोड़ी देर में. But let's take advantage of this. K initial, P initial is K final plus P final. Initially body is at rest and therefore kinetic energy is 0. Height is h and therefore potential energy is mgh. When it is at the lowest point, kinetic energy is half mv square. Potential energy becomes 0. Normally people answer this way. Once I give you this information, normally after I tell them to use COME, they produce an answer like this. What is missing is fundamentals of rolling. If it is in pure rolling, then angular velocity omega is also present. And everybody knows the relation between V and omega. V equals to R omega. What is V? Velocity of the center of mass. That means as this omega is present, you have to take half I omega square also. This wheel has translatory kinetic energy. At the same time, it has rotational kinetic energy. Since two translatory and kinetic energy are both present, you have to include them. So it is better if you use 0 plus 0. In the kinetic energy part, there are two things. First is what? Translatory kinetic energy, and second is what? Rotational kinetic energy. That's your potential. We are interested in V. You can always replace omega with what? V by R. And when you do that, this becomes mgh equals to half m v square plus half I. What is omega? V by R. V by R. So what's the value of V coming? V is coming root over 2 m g h whole divided by m. Now, I hope you remember at this being a question from laws of motion, answer would have been what? Root 2gh. अगर एच हाइट से किसी चीज को रिलीज करते थे लॉज ऑफ मोशन में तो याद होगा v कितना आया करता था रूट 2gh. ट्रिक क्या है हमारे पास? रूट 2gh. Don't forget to add m because we need to divide by m also, and then plus I divided by r square. This is the answer. V is coming root over 2mgh upon m plus I upon r square. In laws of motion, this part is not present. Forget about I. And you get what? mm cancel root 2gh. In rotational motion, when pure rolling is present, your V becomes root over 2mgh whole divided by, हर जगह एक ही चीज कर रहे थे. लास्ट एग्जांपल्स अगर याद हो, m plus the trig part, m plus the trig part. The trig part is what? I upon r square. Note on this and then we'll understand this question further in detail. Now, Let's understand this question, this friction part further. Well, if friction is acting on the body, then the basic concept of CUME, it arrives from this equation. Work done by external force is delta K plus delta P. When we say that there is no external work being done, then these deltas, they become what? The sum becomes what? 0, giving us CUME. On this body, we have an external force of friction present. And the external force is acting up. Body is coming down. Force is acting up, body is coming down. That means it definitely is doing some work. And if it is doing some work, then sum of this and this should not be 0. Normally, आदमी इस तरह से सोचेगा, इसमें कोई गलत भी नहीं है, सोचना चाहिए इस तरह से. सर फोर्स प्रेजेंट है, एक्सटर्नल फोर्स ऊपर लग रहा है, बॉडी आई है नीचे, and therefore some external work is being done by friction. अब इस पार्ट को समझना. If somebody asks you these things in detail, then this part is going to help you a lot. And it will also develop interest in physics, कि भाई कैसे चीजों को करना चाहिए. And if you do not understand it, then just don't worry. You can answer the question in just one line. You don't even have to use this. Simply use the formula and you have the answer. For rotational as well as for laws of motion, you can use the same formula. In laws of motion, simply remove what? I. Now let's understand the role which friction plays in this question. Tell me, this friction is helping V or is opposing V? What do you think? Answer this part. Force of friction, it is helping V, helping in the sense that it is trying to increase V, or it is opposing V, that is trying to decrease V. What do you think? Well, how can it help? It cannot. Why it cannot? This is the free body diagram. In the free body diagram, this force is mg sine theta. And this is your friction. This is the direction of acceleration. In the previous lecture, we had developed what? An equation. And what was that equation? Equation was this: mg sine theta minus fr equals to ma. This equation tells us what? It tells us that this fr is opposing acceleration, which you can see. व्हील कहाँ आना कहाँ चाहता है? नीचे. तो इसका जो V डेवलप करवाया है उसमें किसने पार्टिसिपेट किया? किसकी वजह से हुआ? इसकी वजह से. किसने उस V को डेवलप होने से रोका? Fr. So this Fr is trying to decrease ट्रांसलेटरी काइनेटिक एनर्जी, ये स्टेटमेंट काम आएगा थोड़ी देर बाद. Friction acting up is trying to decrease translatory kinetic energy. It is opposing acceleration, which is basically rate of change of v. Now, इस व्हील के अंदर जो ओमेगा डेवलप होता है, एंगुलर वेलोसिटी, आपको पता है mg and normal reaction. Again, if you are not present in the previous lecture, it's your responsibility. Go and watch that lecture and then you'll understand everything. Normal reaction and mg, they do not contribute anything in torque. Rotational motion develop करने में mg और normal reaction का कोई काम नहीं है. वो किसकी वजह से आता है? Torque of friction, which acts like this. This is the torque of friction. And therefore, there was an equation like this, which was torque of friction equals to I alpha in the previous class. Now, what is that which develops omega? Torque. मतलब क्या? Torque wise friction क्या increase करना चाहता है? Rotational kinetic energy. लेकिन फोर्स वाइज फ्रिक्शन क्या करना चाहता है? ट्रांसलेटरी काइनेटिक एनर्जी को डिक्रीज, विच इज लाइक दिस कि मैंने एक हाथ से आपको 100 रुपीज दिए तो आपको लगा कि कुछ वर्क हुआ, बट देन दूसरे हाथ से मैंने 100 रुपीज ले लिए. सो हाउ मच डिड आई गिव यू? 100 minus 100, which is what? 0. So friction is involved in two ways in the rolling on the incline. एक तो ये ट्रांसलेटरी को बढ़ाना चाहता है, सॉरी, रोटेशनल काइनेटिक एनर्जी को क्या करना चाहता है? इंक्रीज, which is like giving you 100 rupees. दूसरा, when it acts up, it opposes V. ये ट्रांसलेटरी काइनेटिक एनर्जी को डिक्रीज करना चाहता है, which is equivalent of taking out 100 from you. If I take away 100 rupees from you, that means how much did I give you? I didn't give you, but I'm asking you how much did I give you? You will say minus 100. So 100 दिया, minus 100 दिया, कितना दिया? 0 दिया. 100 और दूसरा पार्ट एग्जैक्टली क्या है? minus 100. अगर 80 देगा रोटेशन में तो काइनेटिक से भी क्या करेगा? 80 बाहर निकालेगा. This magnitude will always match provided we have pure rolling at this. अगर pure rolling नहीं है तो स्लिपिंग होगी, और अगर स्लिपिंग होगी तो हीट निकलेगी, और अगर हीट निकलेगी तो इसका मतलब क्या होगा? I'll ask you that. इसका मतलब क्या होगा? अगर हीट निकलेगी तब क्या करेंगे? But right now फ्रिक्शन की जो कहानी है, आई होप आपको क्लियर हो गई होगी. ट्रांसलेटरी वर्क and rotational work, there are two types of work are present. So when you include work, and if somebody is looking only at the translatory part, so you have a wheel. If I have a wheel and not about friction, if something is pushing the wheel, then it is contributing in the translatory part. If something is rotating, then it is contributing in the rotational part. So in case of rolling, you have to include both these contributions, then only you can find total work. अब ये चीजें थोड़ा कॉम्पिटिटिव एग्जामिनेशन ओरिएंटेड ज्यादा चलती हैं, अभी अपन थोड़ा लेवल अपना उठा लें. हालांकि ये भी अच्छा लेवल है अपना, थोड़ा और उठ जाओगे and you will get some स्पेशल लेक्चर्स जहां पर इस तरह की और भी चीजें देखने को मिलेंगी. बट राइट नाउ आंसर इन द कमेंट बॉक्स whether you understand the contribution wise work done by friction and its contribution in rotational and translatory part? Yes or no? Let me see. Good. Almost everybody is saying yes, which is a good thing. But let me see if you answer this part correctly. If slipping is present, then magnitude-wise, contribution of friction will be more in the translatory part or in the rotational part. What is your answer? During pure rolling, they both are what? 100, 100. One is 100, other one is minus 100. For slipping, if friction is not sufficient, then this thing is going to slip. And if slipping takes place, then magnitude wise, in which part there will be more contribution? Think about it. Think about it. Good. That's it. Look. For translatory part, if I say that work done is 100, then it's not 100. First of all, it should be minus 100. Why? It's opposing. And when it's opposing, work will be what? Negative. For rotational part, translatory part, rotational part, work if is plus of 120. Somebody uses this data set कि भाई रोटेशन के लिए फ्रिक्शन ने कितना कंट्रीब्यूट किया? प्लस 120. ट्रांसलेटरी में कितना कंट्रीब्यूट किया? माइनस ऑफ 100. इसका मतलब जो टोटल कंट्रीब्यूशन बना, this total contribution will be what? Plus of 20. But then you know that slipping is present. Friction is not sufficient. We are discussing that case. If friction is not sufficient, then slipping will take place. And if slipping takes place, you know that if slipping takes place, then this type of slipping will produce what? Heat. और हीट का मतलब क्या था? लॉस. लेकिन ये लॉस नहीं है. यहां पर तो आपने क्या कर दिया? प्लस आपने पूरे सिस्टम को एडिशनल एनर्जी प्रोवाइड कर दी. एंड देयरफॉर वर्क डन इन रोटेशनल कैन नॉट बी plus 120. It should be what? It should be minus of 80 type. Not exactly minus 80. It can be minus 90. It can be minus 70. Anything depending on the mu and all. If you have minus of 80, then your W total will be not minus 80, it should be plus 80. It should be plus 80, but the number should be less than what? 120. So this is plus of 80 and this is minus 100. Then what is total? Minus of 20. Minus means heat loss. And therefore we say that this type of thing is not present. Black, not possible. Blue and blue, they are possible. When slipping takes place. If it is pure rolling, it will be 100 minus 100, 80 minus 80, 70 minus 70, this type of data. Otherwise, work done by rotational part, magnitude wise, will be less. There will be more work magnitude wise. Again, remember, magnitude part will be more in the translatory part. Note on this. Now, suppose we do not want to discuss all these things. You're not interested in finding whether work is being done or not, whether we can conserve energy or not. If you're not interested in all these things and you want to simply use a formula, then we can also do that. हमने रोलिंग में एक्सेलरेशन ये लास्ट क्लास में डेवलप किया हुआ है. Remember, only for pure rolling. Now, during pure rolling, what is acceleration? Everybody knows that mg sine theta whole divided by m plus I upon r square. ये किया हुआ है हमने. बॉडी यहां से यहां तक, its displacement is s, and I'm asking you v. What is the equation one should use? This is the equation. V square equals to u square plus 2as. अगर आपको लगता है कि फ्रिक्शन पता नहीं क्या हो रहा है, भूल जाओ उसको. ये फॉर्मूला था एक्सेलरेशन का कर्व ड्यूरिंग प्योर रोलिंग. यूज दैट एंड यू गॉट योर आंसर. U is 0, rest. Acceleration, you have the value mg sine theta whole divided by m plus I upon r square multiplied by s. गौर से देखना, ये दोनों आंसर सेम है. This and the previous one, they both are same. Let's prove it. Look at this term, s sine theta. Look at this triangle. In this right angle triangle, this is s, this is theta, this is h, which is s sine theta. So if we not interested in this much detailing, कोई जरूरत भी नहीं है अपने को. Again, you got the answer in just one line using Newton's equations. You've got u0, you've got the value of acceleration, you've got your displacement. Use these and you get your answer. This is the second method. Note कर लेना, this and the previous one, they are exactly same. Take the square root and you've got the same value. Note down this. Look at this. This angle is theta. Body is a solid sphere. Is released on the incline. Theta is 37. Mu is sufficient. Once S is sufficient, pure rolling will take place. Body is released from rest. It arrives at the bottom with V and omega. What fraction of total energy is present in the form of rotational kinetic energy? Write down the question. What fraction of total energy is present at the bottom of the incline in the form of rotational kinetic energy? Try to answer this, should not take more than 20 seconds. Let's see how many of you can answer this question. The question is that when you release the body from rest on the incline where friction is sufficient, right at the bottom, what fraction of total energy is present in the form of rotational kinetic energy? Fraction means if you say half of the energy is present in the form of rotational and half is present in the form of kinetic, translatory. So that sort of answer I am looking for in this. Well, not a single answer. And look how easy this question is. What is total energy? kinetic energy 0, kinetic energy 0 plus mgh. At the highest point. What is translatory kinetic energy? 0. What is rotational kinetic energy? 0. What is potential energy? mgh. This is total energy. Now tell me, total energy will be more at the highest point or at the lowest point? What is your answer? Total energy will be more at the highest point or at the lowest point? What is your answer? What do you think? देखो इस तरह से कंफ्यूज होते हैं बच्चे. Everybody is saying highest point. जबकि थोड़ी देर पहले मैंने आपको क्या सिखाया? That if it's pure rolling, then it's COME. What is COME? COME means total energy at the highest and total energy at the lowest point, or total energy at any other point is what? Same. ऐसा नहीं कि यहाँ ज्यादा है. Total energy is same everywhere. Because of pure rolling, because of sufficient friction. Sufficient friction will ensure that we have pure rolling. Pure rolling means friction will not eat out any part of energy, and therefore it's same. That's the reason I'm asking you what fraction is present. Now, at the bottom, what is this? At the bottom, this becomes half mv square plus half I omega square plus 0. This is at the bottom. Now, what is the question which I asked you? I'm asking you the fraction f. F is the fraction. What fraction of rotational energy is present at the bottom, and how much is the total energy? mgh. You wish you can write this plus this also, doesn't matter, because this is basically mgh only. So the question is looking for ratio of half I omega square and mgh. Hopefully you understand everything. Now answer this. What is this ratio? The body is what? Solid sphere. I hope we can answer the question now. Look, you need to find half I omega square upon mgh. What is this? This is this. MGH is this. What is this? This is 1 upon plus 1. What is here? M V square upon I omega square. Simple maths. Take half I omega square common. And what do you get? This number. Half mv square divided by half I omega square. Half gone. This. Remember, everything is in what? Pure rolling mode. If this is pure rolling, this is coming what? 1 upon m. और हमने जो लास्ट क्लासेस में चीजें करी हैं उसका फायदा लेते हैं. What is V R omega? Because of pure rolling, make it R square omega square divided by I. If you remember, I used I as C into mr square, and you have the term of omega square plus 1. What is I? C times mr square omega square. M into V. Now, M, V, omega, R, everything is gone. And the answer which you get is C upon 1 plus C, which you can now easily remember because the requirement for mu was C upon 1 plus C tan theta. What is the fraction for rotational kinetic energy? C upon 1 plus C. Take the LCM. This is C plus 1. C jumps. You get this. For any type of objective examination, you can use this result. What is the result? For rotational kinetic energy, this is the fraction. Now, if you remember the result, for solid sphere, what is the value of C? 2 by 5 divided by 1 plus 2 by 5. So your answer is coming what? 2 by 7. This was the procedure. Suppose in school and all they ask a complete subjective question, then use the approach. If they ask this question in an objective examination, remember this, and then it should take only 5-6 seconds. 2 by 7. Don't forget to put the whole result inside the boundary. Mention result, and if possible, make a collection of all these results in a separate notebook. Chapter wise, all the results which you get, leave about have about 6-7 pages per chapter. All the important results which you get, which you think are important in this class or from the booklets and all you got, or from any other place, if you get these results type of thing, just arrange all those results at one place. Make a collection of these, and as I told you, if you remember, if you can have 2,000, 3,000 such results, it's a big task to remember those things, but you can manage that. And if you can manage these 2,000, 3,000 results from 11th and 12th together, then in NEET, JMain and school board type examinations, you will find that you can easily crack 6-7 questions. If you remember 2,000, 3,000, then you crack 6-7 questions in just 5 seconds. What is the advantage? It gives you, first of all, a good feeling once you find that this was the question which was taught to us as a direct result. Well, I'm not giving you only the result, I've given you the exact procedure also. But in any objective examination, there is no need for using all these things. Remember what? C upon 1 plus C for rotational. So if you find a question like this in any examination you are facing, then the first thing you will do what? While you are reading the question paper, so I hope you understand what I am saying. Make a separate special notebook and do everything which you can. By the way, if you understand this 2 by 7 and the process, then write down yours in the comment box. And those of you who will make a separate notebook, as I mentioned, if you will work hard on that part, then write down we will. Don't write yes, write down we will. And remember, I will take note of all the we wills. Let's see how fast you are. What is the ratio of, what is the fraction of translatory kinetic energy in this question? What is the fraction of translatory kinetic energy? What is the fraction of translatory kinetic energy? बड़ा इजी पार्ट यार. अगर एक 2/7 है तो दूसरा क्या होगा? 1 minus 2/7. Total can only be what? 1. This is for rotational. This is for translatory. Just remember for rotational, and if they ask you for translatory, just subtract the ratio from 1. Note down this. And before you note down this, just write down a formula for this profile. If a body is moving with V and rotating with omega, then everybody knows how do we write kinetic energy. Kinetic energy is half mv square plus half I omega square. That's how we write kinetic energy. Whole body having translatory kinetic energy. Whole body having rotational kinetic energy. In rolling, both are present. But if I ask you, what is angular momentum of this body? Then for angular momentum, I need what? A particular axis. Where is the axis? Everybody will say this is the axis. Well, definitely this is the axis. But this is only one of the axes which we are looking at in a given setup. This is the axis. This is also an axis. This is also an axis. Your position as an observer is also an axis of rotation. If they ask you what is angular momentum of a rolling body about an axis like this, then let's call this axis axis O and call this axis center of mass. That's the orientation. A dot means things are coming out perpendicular to the plane. So if I ask you what is angular momentum about O, then the formula is angular momentum about center of mass plus angular momentum of center of mass as a point about O. You'll understand this when I use numerical values, but I want you to write down this formula. First write down this and then you'll write the whole statement also. First use this version, angular momentum of center of mass as a point about O, and we'll write everything in the statement form. Write down this angular momentum of a body, angular momentum of a body about any axis O, angular momentum of a body about any axis O is equal to angular momentum of body about center of mass axis, angular momentum of body about center of mass axis plus, write down everything in the form of statement, plus angular momentum of center of mass, angular momentum of center of mass taken as a point about axis O. देखना भी इधर, this is something which rolls, rolling is present. We have taken an axis over here. This is the axis. About this axis, we are interested in angular momentum. Not necessarily this, it can be this, can be anywhere. We can easily understand in this figure, and therefore I have taken an axis over here. It can be at this place, this place, this place, this place, any place. So, as this ring or disc or anything which can roll, as it rolls, it has what? Translatory plus only rotational part. What is angular momentum about rotational part? What is angular momentum in this case? Write down fast. How many of you remember? How many of you remember angular momentum of a body about its center of mass? This first part. किसकी बात हो रही है? Angular momentum about center of mass axis. This axis. केवल इसकी बात हो रही है. अगर आप center of mass पर बैठ जाओगे, that's not moving for you. You lose what? Translatory motion. Somebody over here at the center of mass axis, what is angular momentum for him? And not a single person has answered the thing which I am looking for, and that thing is I omega. This is I omega. In rotation, when you talk about rotation, what is angular momentum? This was the angular momentum. Now some of you are using L equals to R cross P. This is this, which is the whole thing. What is L equals to R cross P? Angular momentum of a point mass. What is this? A body, a rigid body. A rigid body which has several points. If you want to use this, then you have to take R for every point on the body, and you need to find its linear momentum, which is a mix or superposition of translatory and rotational. Once you do this for each and every point mass present on the body, what do you get? You get this. So, if you want to use R cross P, remember, go and see the notes. R cross P, it was for a point mass, and if you remember, I told you there that R cross P is used for any type of motion. Again and again I have told you that R cross P is for any type of motion. You don't have to have rotational motion. You have the axis, a body is moving straight, use R cross P. A body moving straight, you cannot use I omega. I omega was fixed for this type of thing. You have the axis and the body is rotating all about. So, forget it, there is no need for this much detailing as of now. Remember the formula and its application, which is of just one line. So, what is angular momentum of a body about center of mass? जब हम बोलते हैं सेंटर ऑफ मास के अबाउट, तो फायदा क्या होता है? बॉडी केवल ऐसे ऐसे घूम रही होती है, which is I omega plus. Now, what is this? Center of mass as a point. और ये क्या था? Angular momentum of a point. तो अब हम क्या करेंगे? Center of mass, especially in this case, let's talk about. इस सेंटर ऑफ मास को अगर हमने क्या बना दिया? पॉइंट, तो आर क्रॉस पी किस तरह से ओपन किया था हमने? आर क्रॉस पी को ओपन करने का तरीका मैंने ये सिखाया था, लीनियर मोमेंटम मल्टीप्लाइड बाय परपेंडिकुलर डिस्टेंस ऑफ लीनियर मोमेंटम फ्रॉम द एक्सिस ऑफ रोटेशन. दिस इज द एक्सिस ऑफ रोटेशन and this is your linear momentum. बॉडी की बात नहीं हो रही है, ध्यान रखना क्या लिखा हुआ है? सेंटर ऑफ मास, कंसीडर इट एज अ पॉइंट, रिमूव एवरीथिंग, कंसीडर ओनली अ पॉइंट मास ओवर हियर which is moving like this. What is its angular momentum? That is given by this. So what is the angular momentum? Linear momentum multiplied by perpendicular distance, which is R. This is your linear momentum. Its perpendicular distance is r, which becomes what? I omega plus, what is P? M into V into R. Not for pure rolling, for any type of rolling, any type of rolling. If it's pure rolling, you can replace V with what? R omega. For any rolling, if they give you a question like this and then they ask you what is angular momentum, this is the answer. Put on this much. And you will understand the advantage of taking an axis outside of the body in just a minute. Let's do it fast. As of now, remember the formula. And whenever we conduct offline classes, which we are going to start soon, I will try to give a proof of this becoming this. लेकिन अभी के लिए बस मान लो कि हाँ बहुत सही चीज ऐसे होता है. Look at the question which we are interested in. A question which you can also conduct yourself. Take a ring or a disc or anything which can roll and give it a translatory motion V. Once you give it translatory motion, omega is 0. Let's say V initial, omega initial. Omega initial is 0 and V initial is 10 meters per second. Look here. This is V initial part, 10, omega initial 0. Let's make it V final. V final and omega final. The question is, we have a body, take its moment of inertia I, mass m, radius r, and it starts from this position and you only gave it some speed, V initial. As I told you that you can conduct this type of experiment at your place. Hold a wheel, do not give any rotational thing, just give translatory velocity. And the moment you give it translatory velocity, it automatically starts doing what? Rotational motion. And then it is a mix of translatory as well as rotational part. But initially, this contact point will slip. Why? Because there was no pure rolling present. We only gave it what? Translatory motion. If I give it only translatory, hold a wheel or a coin and then move it without rotating. And as you move it, you can feel that the lowest point, it slides against your hand. If it slides, it will slide definitely in the forward direction, which will produce a frictional force acting in this direction. Initial. So if you only give speed, translatory, you do not provide any rotational, this is the friction which is acting on the body, and this friction is going to do what? Tell me fast. What is this friction? This friction is going to increase speed, decrease omega, decrease speed, increase omega, decrease both, increase both. What do you think? Write down this fast in the comment box. Those of you can. What do you think this friction is going to do? Well, I hope everybody can see this. Body is going in this direction and friction is opposing it, and therefore V is going to decrease. Now what about omega? Omega present नहीं है पहले. मैंने आपसे क्या बोला, आप फील भी कर सकते हो. एक व्हील को आपने थ्रो किया है केवल ट्रांसलेटरी, तो ओमेगा किसने दिया? आपने नहीं दिया था. ओमेगा किसने दिया? इस फ्रिक्शन ने. क्यों दिया? Because this is the torque. This is the torque of friction about this axis, about center of mass axis. This is the torque. So this torque increases what? Omega. इसकी वजह से यहां पहुंचकर क्या डेवलप हो गया है इसके अंदर? ओमेगा फाइनल. V क्या हो गया है? डिक्रीज. तो ये फ्रिक्शन जो पीछे की तरफ लग रहा है, ये क्या करता जाएगा? ये V को डिक्रीज करता जाएगा, ओमेगा को इंक्रीज करता जाएगा, and then a time will come when V is R omega. V डिक्रीज हो रहा है, ओमेगा जो जीरो था वो इंक्रीज हो रहा है. A time will come when V will be equal to what? R omega. V final, this omega final. This is the moment which is known as pure rolling. और जैसे ही प्योर रोलिंग होगी, शायद याद हो आपको, फ्रिक्शन क्या हो जाएगा? जीरो. क्या हुआ है अपन में? तो ये फ्रिक्शन जो पीछे लग रहा था, थोड़ी देर बाद इसके अंदर V और ओमेगा इस तरह से एडजस्ट कर देगा. प्योर रोलिंग. अब ये कॉन्टैक्ट पॉइंट स्लिप नहीं करेगा. ऑन horizontal surface in the absence of other forces. This was the statement. Friction becomes what? Zero. अब फ्रिक्शन नहीं है. अगर फ्रिक्शन नहीं है तो याद करो मैंने इस तरह से समझाया था कि अगर आप काश्मीर से चलोगे, एक ट्रैक बनाओगे, प्योर रोलिंग मोड में है, तो आप कन्याकुमारी तक जा सकते हो, प्रोवाइडेड थिंग्स आर फ्लैट. आई होप यू रिमेंबर दिस टाइप ऑफ स्टेटमेंट. इस जगह के बाद अब आपका फ्रिक्शन काम करना क्या कर देगा? बंद है ही नहीं. Now everything, you're not interested in all these things. The question is, we need to find V when pure rolling starts. Now how easy it is to answer the question, because we have not sufficient time, I'll answer it quickly. Try to understand this. If somebody keeps on finding torque about this axis only, then he cannot use COAM. COAM. Why you cannot use COAM about this axis? Because torque of friction is present. So what we did, we took an axis over here. Call it axis O. Now what is special about axis O? Force of friction is passing from the axis O, and therefore torque of friction about axis O is zero. और जब टॉर्क जीरो होता है तब आप क्या कंजर्व करते हो? एंगुलर मोमेंटम. Remember the examples of belly dancer and all which I gave you. Can I conserve angular momentum about center of mass? No, I cannot. Can I conserve about this axis? Yes. What about mg? That is cancelled by normal reaction. उसको सोचने की जरूरत नहीं है. Friction की टेंशन थी. The moment I take axis over here, that is gone. Now, If I can conserve angular momentum, then let's conserve it. L initial equals to L final. What is the formula for L initial? Angular momentum about center of mass axis, what omega is 0, plus angular momentum of center of mass about this axis, क्या था वो? M, V, how much is that? 10 into radius, whatever that is, R. ये क्या हो गया तुम्हारा? Initial setup. L final. What is angular momentum over here? Angular momentum about center of mass axis. What is that? I into omega final plus M into V final multiplied by R. Done. क्या शुरू हो चुकी है? प्योर रोलिंग. इसकी वजह से ओमेगा और V रिलेटेड हैं. So you can replace omega with V final upon R. They will give you the type of body. You have the value of I. Put it in this, and in just one line using COAM, we can find and solve the question. Now, I can understand that this is something which you are looking at. This type of examples you've not done a lot. In fact, this is the very first example, and you will find it difficult. But try to solve this question on your own. This type of profile again and again. Take my help. Solve these questions from the booklet which I have given you, and ultimately you will gain confidence. And you will find that physics is not difficult. It's about learning which format should be used. This is not the only way. This is the best way. You could have found V and omega with the help of V equals U plus AD also. Force पता है, decrease हो रही है V. You can find A. ओमेगा आप increase कर रहे हो. ओमेगा कौन increase करता है? अल्फा. You can find torque. उससे भी हम निकाल सकते हैं. But that will take time, and we'll see that type of thing कभी और. As of now, note on this, and if you understand again 60-70% or more, then write down yes in the comment box. And if you do not, then just don't worry. ये चीजें प्रैक्टिस के साथ धीरे धीरे दिमाग में घुसती हैं. Put on this much and then you can leave. Thank you very much.